Yeah, so thanks a lot for the kind introduction. Yeah, my name is Julian. I'm the Vice President of Electronics and Software for Delta Vision, where we fuel space mobility. So what do we need mobility in space for? That's the first question. So um, one important thing is to have satellites which are able to move faster than the satellites that we have right now and move more. So we have, for example, threats from military where probably in the next 10 to 20 years we will see interceptor satellites, and also we have different applications which require fast orbit changes. So we need mobility for satellites. Also, mobility enables different exploration approaches. So, for example, if you want to go to the moon and take more cargo with you, then you will need mobility, and you need different key elements for this mobility, which are, first of all, of course, the ability to move with trustable propulsion and high trust propulsion as well. And also, if you want to move a lot, you need to refill your system. So you need propulsion and fuel for this propulsion. And that's exactly where we jump in. So our backbone is to produce fluid components for high thrust propulsion. So we have multiple solenoid valves. We are currently developing pumps. We're developing motors for these pumps and for these valves, and also pressure regulators. So everything to control fluid. And we were founded in 2022. Already a team of 50 people with 4 million of revenue. Already have 30 plus global customers. So we had customers from day one basically, and already have several products in space after only 3 years of funding. And what is also important, as I just said, is to also provide the fuel in the system. So using all those components, the next step is basically to enable orbital fuel transfer. So we're currently working on that. We have a demo payload which will go into space next year, where we also have the first European single-line fluid coupler. Also yesterday we were awarded with a tender from ESA, where we develop a fluid coupling system together with OHB and Airbus. So yeah, what's the roadmap of us? With the fluid refilling system, we want to become globally visible next year after launching this device. And then extend towards a global player and a global leader, also with extensions into different countries, into France and the US, which is currently planned and yeah, estimated to be happening around 2030. All right, so now to get a little bit more, see how we work, I also have a video for you. Yeah, so that's it from my side. Thanks a lot. Actually, the video would have had sound, which would it be a little better, but yeah, still, I think it gives you a good understanding how what we're doing and where we're going currently. So you can meet us. We're just around the corner. If you want more information about our products, we also have our COO with us who can tell you a lot about the mechanical stuff, and I can tell you about the electronics that we're developing in more detail. So, yeah, come and visit us. Thank you.
Thank you, Julian. Does someone have a question from the audience? So that was really clear. Thank you again. Thanks.
Thank you very much.
Thank you. Okay. So the next to pitch is Philippe from Leolab. So I welcome you on stage. Sorry.
From Leo Blue.
Leo Blue, Leo Blue. Sorry. Thanks. Merci. And ouais. Yes. Et
Ok, super.
thank you.
Hello everyone. So I'm Philippe Latte. I'm founder of Leo Blue company. So the recent disasters in Mayotte and in Valencia last year have shown that even in developed country, we are not longer safe. In Valencia, the people were not be warned in time for the flood. In Mayotte, 95% of the network were destroyed during the cyclone, the storm. And the French government had to buy Starlink antenna urgently to be able to communicate with population. So the number of disaster is increasing about 16% each year, affecting 170 million of people and causing almost $300 billion of damages. So we know that informing people before and after the disaster reduce drastically the losses. But most of the population of the world is not equipped with alert system. Why? Because the terrestrial system, like 3G or 4G antenna, are covering only 10% of the planet. And these systems are very fragile, as we've seen in Mayotte. There are some promises from mega constellation, like Starlink. They say that they will provide some alert system at the worldwide level, but this system will remain expensive, complex, and there are some main issue of sovereignty, because this means that your alert will go out of your country. But the solution is maybe in your pocket, because you have in the pocket your smartphone, and all the smartphones of the world, they have one common thing. It's a Bluetooth chip. The 8 billion of the smartphones in the world, they have a Bluetooth chip. If we are able to send messages directly from satellites to smartphone using this Bluetooth chip, it could be a revolution, because you can address everyone on the world. Today, no one had considered the usage of Bluetooth to send message on a large scale. Why? Because everyone is thinking that Bluetooth is a short-term communication. But in fact, it's false. So we have developed a patented technology that allows the transmission of Bluetooth message over several hundred of kilometers. And last week, we did a prototype test under a stratospheric balloon of a CNES at 16 kilometers with only 1 watt of emission. So we have shown that it's not the distance is not a problem. So we are a solid team. I'm working in space industry for 35 years, in Airbus, in Aerospace Valley, in other venture. My co-founder is a researcher in telecommunication. And we have a very strong board. In particular, we have an inverter of Bluetooth who is supporting us for this, way. So we are currently raising 1.4 million of euro to develop our first payload, which will be quite small, that we could embed on host satellites to make a demonstration, a real demonstration next year in orbit. Our approach is very fast and lean because we are using only existing satellites. We are not designing a new constellation. We are using existing satellites. We are using free frequency because Bluetooth is a free frequency. And we are using standard smartphones that are already in the world. And we intend within 3 years to create the first sovereign, universal, and very affordable network for the crisis management. Almost billion of people are waiting for this kind of technology to be alert and informed. So we have to be very quick to develop this system. Thank you for your attention.
Thank you, Philippe. Do you have any question on the audience?
Yes?
Oh, there is several. The mic is coming. No,
okay.
wait.
So
Thank you very much for a nice talk. It's a very interesting technology. Just one question, because I'm not really expert. Why is using RF signal too expensive? I guess it's too expensive. It's not really possible. Why is it so?
why is it, sorry?
Why is RF? I think typically communication use RF signal, isn't it?
RF, yes?
Which has a longer, like I guess the typical there. So why not using RF but using Bluetooth? Is there any? Yeah.
Why using Bluetooth? It's very simple because everyone has Bluetooth in his pocket. So the main interest is to build a network which is able to communicate with all existing devices in the world. So this is, we can say, very, very different from all the direct-to-device system that they need specific terminals or new terminals. Exactly. So the interest is to be able to communicate with 8 billion of existing devices, and as well for the 30 billion of objects that have internally a Bluetooth chip. So why Bluetooth? It's really because it's a standard, and if we are able to be in this standard, we will become an extension of the standard in space. It is clear? Yeah.
Thank you. I saw also another hand raised.
Yeah, thank you for the pitch. I also have a similar question because currently mobile phones, they have a certain frequency band which is used just for this notification, while Bluetooth is not designed to alert something, for example, because it's usually a communication protocol where you have to verify connection and stuff like that. So yeah, also a similar question, why are you not if it's possible with the 2.4 gigahertz frequency to achieve the long range, why is it not possible with the normal alerting band, kind of?
Okay, so the first part of the answer, we are using a specific protocol within the Bluetooth norm, which is very huge. There is one specific protocol which is not, which is a broadcast mode. It's not the same mode that you are using for your iPhone. So this means that we are unidirectional. This is changing very fast because we don't have the problem that have all the direct-to-device system to establish the link between the smartphone and the satellites. Because the difficulty, it's not for the downlink, it's the difficulty, the uplink. Because when you are in satellites, you have a noise in your frequency, which is a very huge problem. This is why the direct-to-device system, they have a very small spot on the ground, like Starlink, it's 60 kilometers, because you need to be very precise. If not, you are not able to get the information. And so with this system, you need a lot of satellites because you have only a slot of 6 T kilometers. In our case, as we are only directional, we have a spot which is 800 kilometers large. And maybe we can do till 1,000 kilometers. So this means with one passage, one way, you are able to send information to the whole France, for example. So this means it's you need much less satellites to send information rather than all the constellation system. Due to the fact that we are not bidirectional. We don't need to be bidirectional. It's impossible for Bluetooth. It's impossible to make. It's impossible. Impossible doesn't exist, but it's very, very difficult. We don't see how to make the link because you have too many objects that they are emitting. And the other aspect is the fact that we are using a free band, so we don't have to negotiate with each operator in each country for using the band. So it's for alert system, it's very key. But because this means that you have one satellite and then you are able to send information everywhere without discussing in each country with the owner of the frequency. So basically they are different. I don't know if I answered to your question.
Yes, you did. Thank you.
Thank you.
Okay, great. Thank you, Philippe, again. Okay, so I would like to welcome on stage Théophile from Space Locker. He's on his way, just coming.
I'm here. Thank you very much.
5 minute and 2 minute pitch. 5 minute pitch and 2 minute Q&A, sorry.
Thank you, Marie. Good morning, everyone. So my name is Théophile. I'm the co-founder and CEO of Space Locker. And at Space Locker, we're expert in orbital hosting. The first step of my speech is that we all know a bit about space companies, about how they dream about sending in multiple sensors in orbit, etc. But there is one major point, is that we're all talking about that in a room, and we never met the complexity of building a mission. But actually, building a space mission is extremely long, extremely complex, and also extremely costly. And so space mission as a whole remain inaccessible. And even this small mission, which is like on the screen, you have a 3U under integration. Even a 3U is probably, like a nanosat, is probably 2 years of development from the beginning of the project until the launch of this satellite. And so there's a real need for the space industry today to find a way to make the deployment of sensors much more easier than what it is actually. And so that's the mission we have at Space Locker. We have to simplify and to make space more accessible without creating yet another satellite manufacturer, but by democratizing satellite sharing. Because we are convinced, and I'm going to show you why, that satellite sharing is the key to make space sensors deployment easier, faster, and more sustainable. So First, it's cheaper. It's cheaper, why? Because you mutualize the infrastructure below the sensor. So we are hosting sensors on board satellite that have about 5 to 10 customers on board, and so you divide this the cost of the satellite, the cost of the launch, etc., per number of sensor, and so it's extremely efficient in terms of cost of the mission. Then it's much faster too. It's much faster, and you can see it on the screen. We have the integration of one of our customers on the second mission that we're launching in a few months. It's a mission that has been integrated in 30 seconds. And I'm not kidding when I'm saying 30 seconds. It's really like the timing that we had. An equivalent mission would have taken at least 3 months to be integrated inside the satellite. So it's not magic. It's really linked to the technology we've developed, to all the processes, etc., that we've enabled. And it's linked to the fact that the customer has all the autonomy to develop his payload, so his sensors or his instruments, on his behalf, and so autonomously with all the elements, as you do, for instance, when you deploy software on board a cloud infrastructure. Well, you have all the development kits needed to develop your software. So that's a bit the same philosophy that we're applying here. And the last point is that it's more sustainable. Why is it more sustainable? Well, first, regarding the footprint on the ground, we reduce the mass sent by approximately 30%. And the mass sent is directly linked to the carbon footprint of a mission. That means that we reduce the emissions linked to the manufacturing of the satellite, but also to the launch of the satellites. So it's the first point. But then there's another point about sustainability that is crucial for the space industry, is that we reduce the number of debris created too. We actively reduce the number of debris because instead of sending 3, 5 small satellites that would have a very low reliability rate, we are aggregating them on board very large satellites that have much more collision avoidance, deorbiting capability, etc. And it's a very important problem for the space industry currently, and it's also a problem for operators because they are more and more pressurized by regulation regarding debris. So how do we do so? Because it's easy to say, it's much harder to do. We've developed a unique technology of a universal space port. It's kind of a space USB that enables us to have a plug-and-play integration of our payloads. I talked about the fact that we're integrating much faster our payloads on the previous slide, but you see it how we do it. So we send containers to our customers. They develop their payload within those containers. So let's take the example, if you have a camera and you want to send it to space, well, we will send you a container, the size of the camera you want to send. You will integrate this camera inside the container that we've sent you with all the development kit that is delivered with it. And then you'll ship us back the container with the camera or any payload inside it, already integrated and ready to fly. We then integrated onboard an existing satellite that is equipped with the Space Locker interface. And the Space Locker interface that we call the lock is an interface that does the power distribution, the data conversion, and all the features that make the integration seamless for both the host and the hosted payload. It's not only a PowerPoint presentation. We're already flying. We already have 3 customers at 500 kilometers above our heads. So we have a first mission, and we have 5 missions coming in the coming years. So about 20 customers ready to be deployed and under integration. So we're already a company space-born with one of the fastest developments in the space industry, because we're one of the fastest companies to have sent the first commercial mission in orbit. And we're not stopping there because we're growing to 20 by the end of the year. We are heavily recruiting, so if you're interested, please contact me at the end of this pitch. We have signed numerous customers on the commercial side, but also on the institutional side. We're working with ESA, we're working with CNES, and several space agencies. And we already implemented in Paris and Toulouse with 2 sites. So at Space Locker, we believe that the future of space is a shared space. We believe that shared satellites are the future of the industry and that they are the answer to deploy sensors in a faster, cheaper, and more sustainable way. Thank you for your attention. I'm Théophile for Space Locker.
Thank you, Théophile. Do we have any question from the audience? There is one. Attends.
Yeah, thank you very much for nice talk. I quite like the idea of the shared space. The space is shared space, but I also wonder, is it really the case? Do you see any barrier making this concept very difficult to be implemented in terms of the kind of politics and so on? And how do we unlock this kind of like barriers? Do you have any idea? Yeah.
So yeah, it is the case, and there are several factors pushing for a shared space. And you have the first one that is really a business case that is currently, like, we're sending a lot of nano satellites. It's one of the answers to the industry to make space more accessible, but we're already seeing the limits of those satellites because they're very not reliable. Most of, like, you have approximately 40 to 50% of failure rate on those satellites. They're not sustainable, and they're extremely costly because when you send a very small satellite, it's nice because it's a small sat, so it's not super expensive, but you have incompressible costs, such as the solar panels, the onboard computer, etc., because you have elements that are needed no matter what you send. So you have this incompressible cost basis that is actually not scaling linearly when you have a larger sat. And so when you start having a larger sat, you have much more performance subsystems, etc. And mutualizing them enable you to make those quality system accessible to a lot of customers. So that's the first business case, let's say, that the industry is more and more looking at quality for same price rather than to decreasing the price at like crazy low prices. Then you have a regulation part on the institutional part that is really, I think, getting more and more important, especially in Europe or in advanced space nations, let's say, because the debris issue for the space industry is something that is really starting to become a threat for most operators. And the only way to solve that is to have a regulation that will push operators to mitigate those issues. And so we have a lot of examples at the French level with the laws that has been there for a few years, but also at the European level, that the debris mitigation is something that is starting to be increasingly important. And satellite sharing is probably the only active solution to reduce this threat at the beginning. Because we can clean space, but trying to reduce the number of debris created is much harder.
Great, thank you very much.
Thank you. Any other question? Okay, so I think it's all clear. Thank you
Thank you
again,
very much,
Théophile.
Mike.